Hi.
Right.
Okay. Good evening, everyone. I'm Nikita. I'm a PhD student from IIT Madras, and I'm your NPTEL PE for the course Basic Environmental Engineering and Pollution. So this is week 12 of the live class, and this is the final week. But there will be an extra session on Thursday in case if you have any doubts. So there we'll be reviewing all the topics that we've seen so far. So it will be a brief review, and yeah. So if you have any questions from the previous class, let me know. Okay, is my screen visible? Okay. So first, we will look at air pollution management. So tell me, why do we need to manage air pollution? Why should we manage air pollution?
Your screen is not visible.
Is it visible now?
No, ma'am.
Is the screen visible now?
Yes, ma'am.
Yeah, okay. So, why do we need to manage air pollution?
To prevent the health from being deteriorated.
Yeah. And how do we do that? How do we prevent air pollution or how do we manage air pollution?
By using air controlled instruments or equipment.
Okay, that is the second step. So far we have seen in the course, the first step is to eliminate the pollution from the source itself. So if someone is emitting pollutants, then it is necessary that they should use raw materials, or if some industry is polluting, then the raw materials used should not be polluting. The processes should be changed in such a way that the pollution is emission is very low. So the first step is reduction. So the first step is reduction. And then we also can eliminate the pollutants. So that is the second step, elimination. So the first one is reduction. The second one is elimination. So why do we do this? To reduce the effect of pollution on humans. Okay, just give me 2 minutes. I'll. something called emissions inventory. So what is an inventory, Jana? Yeah. What would be an emissions inventory?
Carbon dioxide,
Sorry.
CO2,
CO2, no. Not just CO2 actually.
NOx, SOx.
Okay, what are all these?
Sorry,
What are all these? Like what you're saying, you are giving examples of what? NOx, CO2, and all. What?
ma'am, emission inventory,
Yeah, but you are talking about NOx and CO2. What are they? What are they called actually?
gaseous pollutants.
Yeah. So an emissions inventory is a list basically. So it is a list, and so what does this list have? It lists the sources and like it will tell us the pollutants, like where the pollutants are coming from, the source of the pollutant, and the amount of pollutant, and it also tells us like how much is generated over a period of time. So that is an emission inventory. It's like an inventory or a stock of pollutants. So it will tell us how much of pollutant is being generated, from where it is generated, and for what duration it is being generated. So this is used for designing air surveillance systems and for making the standards. So if we have to make a standard for something, first we have to know what is the pollution level and where is the pollutant coming from. So for that we need to have an emission inventory. Like if you are giving a standard for a particular region or for a country, then we have to know how much of pollutants are there, what are the sources, and like we need to get an idea of this. So this is done during an emission inventory. So it consists of 5 volumes. So the first volume is uh, just the fundamentals of emission inventory. The second volume is methods of collecting and handling emission. And this is especially for sources that are too small or that are too numerous. And then the second one is point source identification. The third one is methods of collecting and handling emission data. And the fourth volume is an overview of the mobile source category. And the fifth volume is the list of currently available reference material. Is my writing visible?
Yes, ma'am.
Okay. Now let's look at air pollution control in industries. So the first kind of pollutant is gaseous pollutants. And the second one is particulate pollutant. So gaseous pollutant generally gaseous pollutants in industries are removed using what method?
Why don't you use the pencil? I mean, light pen.
So we were looking at methods to control gaseous pollutants in industries. So based on what we've seen so far, can you list what methods are useful for controlling gaseous pollutants? You must recall something called adsorption, right? What is adsorption? What is adsorption?
It is a phenomena where particles stick to the surface.
Yeah, it is a surface process where the particles are bound or they form chemical or physical bonds with a material on the surface called an adsorbent. So that is a popular method for removing gaseous pollutant in industries. And there is another method called combustion. So this is useful if the gas is combustible Like if we have something like a biogas or something that needs to be let out, then we can use combustion to remove any volatiles present. And then if we have particulate pollutants, what is the method that we can use to remove them? How can we remove particulate pollutants in industries?
No idea.
We have seen, no, like in the previous lectures we have seen, and you also have watched the lectures online. There is something called a gravitational settling method. So, gravitational settling. And then there is also cyclone separation. And then we discussed about fabric filters and electrostatic precipitators, wet scrubbers. All of these were used to remove particulate pollutants. So, can you differentiate between a cyclone separator and a gravitational settler?
Gravitational settling works on the principle of gravitational force, while cyclone separators works on the
Okay, what?
principle of centrifugal.
Can you explain how this happens in gravitational settling? What actually happens? How are pollutants removed in a gravitational settler?
We can decrease the velocity of these particles, so we can let them settle out due to gravity.
Yeah. And what happens in a cyclone separator?
It works on centrifugal force, so we apply external force like high pressure and like radial force. Like pushing them out.
Yeah. And what about fabric filters?
It's like a filtration process where
Okay.
the pores are separate them out.
Okay. And out of the three, which one can be used for removing particles, very fine particles, like which are in the micron scale?
From fabric filter.
Yeah. And what about electrostatic precipitation? What is electrostatic precipitation and how does it work?
Like it's basically making into a precipitate form, and the precipitate will settle down.
How do you make a precipitate if you have a particulate pollutant in air?
adding ions or something like that.
Ions are charged particles, but how will you get them if you? I mean, these are just particulates that are suspended in air, right? So
Yes,
how will you ionize them?
adding opposite charge.
Adding opposite charge. So there is electrostatic precipitation, right? So what is the significance of this word electro?
Electron. Like dissociation or splitting of an atom.
See, in electrostatic precipitation, we use two plates, okay, and we connect it to electricity. So one of the plates is positively charged and the other becomes negatively charged. So these particles they get attracted to oppositely charged plates. So if the particles are negatively charged, then they settle on the positive plate. And once we remove the current, whatever charge was holding them together will cease to exist. So then the particles will all fall down and they will be collected. So this is what happens in electrostatic precipitation. What about the last one, wet scrubber?
Ma'am, where water is added from the top and
Okay.
gases from the bottom, so
How
they
is water
will.
added? Can we just pour water?
I mean, water is sprayed like into a jet form.
Jet.
I mean, water is sprayed generally from the.
Water is sprayed as very fine droplets. So when we have such small droplets, they can easily interact with the dust particles or particulate matter. If you have a very high stream or if you have a jet, then the particles will not come in contact with water properly. It will repel them. I mean, not repel, but it will prevent their mixing. So that is why we use very fine droplets in wet scrubbers. Okay, so this is about industries. So on a personal level, if someone owns a vehicle, then what should they do?
Sorry, ma'am, can you please repeat the question?
If someone owns a vehicle, so in that case, what should they do to minimize the pollution from the vehicle?
Ma'am, use alternative fuels or EV instead,
Yeah,
or like
and if we have a conventional vehicle, then
ensure that the engine is like 100% efficient. If it's not efficient, then we have to like maintain it or keep checking.
yeah, so we need to regularly maintain it.
Yes, ma'am. And another can be like related to law.
Yeah, this is mandated by law, regular maintenance and
Yes,
inspection.
or ma'am, we can use pollution control uh, outlets. I mean,
Yeah, that is already in existence. All vehicles have a catalytic converter attached to them.
yes, yes.
So there is a cycle for air quality management. So the first step of this cycle is to establish goals. What this means is we need to form a goal of what we want to achieve, like how much of uh, like if there is pollution, then we need to remove it. So that becomes a goal, and how much we have to remove it, that also. So that is the first step, to establish goals to remove the pollutant. And the second one is to determine the emissions reduction. The third step is to develop control strategies. So the second step means we have to identify how much of reduction is required, and accordingly we have to develop control strategies or methods to reduce the pollutant. And then we have to implement these strategies. And then finally, after implementing these steps, we have to evaluate. So without evaluation, we cannot just predict how much has been removed. So we also, after following all these steps, we again need to go back and evaluate. And then if the levels are low, then it is fine. But if still the pollution has not been controlled, then we need to review all these steps and then change them accordingly. So the Central Pollution Control Board has initiated the National Air Quality Monitoring Program, or NAMP, to monitor selected pollutants at certain locations throughout the country. So there is something called air quality survey. So it is just like any other survey. So we will identify the source of air pollutant, and then we also have to look at how the pollutant can be removed, if there are any if there are any issues with the ventilation and so on. So this is done using some interviews, like how we generally conduct surveys, and then site inspection. So this is just like a monitoring method where we go on site and then we measure how much pollutant levels are there. So we've already seen how to sample pollutants. So using those techniques, we will take samples and then we will analyze them. And the third one is environmental evaluation. So environmental evaluation means analyzing the pollutants and deciding if it is below or above the standards. Okay, now moving on to objectives of air quality standards. So the objectives of air quality standards are to indicate the level of air quality, and establish priorities for abatement and control of pollutants. And the third one is there should be uniformity in assessing the air quality, because if if every place has its own standards, then it won't be good. So we need a uniformity in the assessment, and that is the third point or the third objective. And then we can have a tool like air quality index. So just like water quality index, and air quality index is used to uh, talk about, it is used to communicate about the air quality in a particular region. So it is basically a number. So the number will tell how good or how bad the air quality is. And it is not just one or two pollutants, it's a combination of multiple pollutants, and based on their concentrations a number is assigned. So in this one number, there this number is decided based on the concentrations of 8 different pollutants, which is PM10, PM2.5, NO2, SO2, carbon monoxide, ozone, ammonia, and lead. So even if only 3 pollutants concentrations are present, even with that, the data can be calculated. But one of them should strictly be PM10 or PM2.5. The other one can be any of these gases. So for calculating the AQI, there are 2 steps. The first one is formation of subindex for each pollutant. And then aggregation of the subindices to get overall AQI. So now we look at the method of calculating the subindex. So the subindex is denoted by I, and the pollutant concentration is denoted by X. So I equals alpha X plus beta. So alpha here is the slope, and beta is the intercept. So So if you have a plot between uh, the subindex and the concentration, and in case you have a linear relationship, then and if there is a linear relationship like this, so this here is alpha, and the slope is, oh sorry, the intercept is beta, and the slope is alpha. So this is how we do step 1. We can use this equation to find out the subindex. So this is the subindex and x is the concentration. And the next step is aggregation of subindex or aggregation of I. So this can be done in many ways. The first one being the weighted additive form. The second is the root sum power form. The third one is root mean square form. Fourth one is the minimum or maximum operator. And then there is the green index. And then there is the air pollution index. And then the most undesirable, respirable contaminants list or contaminants index. Which is MURC. And then there is Oak Ridge Air Quality Index, just abbreviating it. And then finally there is Indian Air Quality Index. And there is something called special waste. So a special waste is a solid waste that requires special handling, which is quite similar to hazardous waste, because its quantity or the concentration of the waste is too high, and it cannot be disposed or handled in a regular way. So those kind of wastes are called special wastes, but they are not hazardous. And they can be categorized into biomedical waste, and e-waste. So these two categories require special handling. So what is biomedical waste?
Ma'am, the waste which is generated from hospitals, healthcare centers, laboratories, or etc.
Okay, why are they called biomedical waste? What is generated in hospitals?
Ma'am, tissues, syringes, etc.
Why are they? Why should they be disposed carefully?
Because they can infect other people
How?
by blood,
Yeah, that's what I'm asking. What do they contain?
pathogens.
They can have pathogens or any chemicals that are infectious, or no, sorry, which can be affecting others. And this can also come from research labs or funeral homes.
Yes, ma'am.
Yeah. So examples of these wastes are blood, sharps. Sharps means knife or any other equipment that is used to cut human tissues. And microbial culture, any tissue or lab waste. So they can also come from places like restrooms, kitchens, even hostels, administrative places, etc. Depending on the type, biomedical waste is divided into 8 categories. So we are not going into that now. So we look at how this waste can be managed. First step is collection. So the waste must be collected separately and stored separately so that it doesn't contaminate other wastes. And based on the type of waste, there are different kinds of bins. So each bin is colored depending on the type of waste that is collected in the bin. So yellow colored bins are usually for sharps. Sharps mean knives or uh, anything which is used to cut human tissues. And then blue for glasswares or any metal waste. And red for recyclable contaminated waste.
Syringes.
They come under sharps.
Okay.
Okay. And the next step is segregation. So segregation is separating the waste so that it does not contaminate any other waste. So segregation ensures that like we can reuse the waste after recycling it properly. And then we also need to store it properly. So storage location should be available in the premises where it is generated. And also the time of storage should not be more than 72 hours. In winter,
Now, why there is a need of this step? What if we like go for transport directly?
but what if the transport or any processing facility is not in the vicinity? Then it won't be possible to collect every day, right?
Yes, ma'am. Yeah, for that, it requires storage.
Yeah, and if the quantity that is coming is very small, then it doesn't make sense to collect every day. So that is why we are storing it, and after some time, after maybe once in a week or so, it is collected and then transported for a processing facility. So in winters, it should not the storage time should not be more than 72 hours, and in summers, it should not be more than 48 hours. So this is the rule for temperate climate. If we have, if the place is quite warm, then in winter it should not be more than 48 hours, and in summers it should not be more than 24 hours. And also, if we have radioactive waste, then that can be stored behind lead shielding. This fourth step is transport.
And also, concrete is used for covering the radioactive waste, I
Yeah,
think.
lead is used.
And what about concrete?
Concrete cannot hide your radioactive waste, right?
I mean, in Ukraine, after the Chernobyl incident, they have covered with this concrete.
Okay, have you heard of this scientist called Marie Curie?
Yes, yes.
Her tomb is covered with lead because her body is highly radioactive, so it has been covered with lead.
Okay.
Okay, the fourth step is transport. So within the premises, we can, if the waste is in large quantities, then we can use wheeled trolleys for transporting. And then if we are transporting from the premises to other places, then we have to use sealed bags. And radioactive waste should be kept in containers that can be decontaminated. And pathogen containing waste must be labeled properly. And in general, all waste bags must be labeled. And the next step is treatment and disposal. So for this, we can use destruction, which includes incineration, using plasma arc. So basically, this is burning the waste so that all the pathogens, etc., are completely destroyed. And if we want to reuse the waste, then it is good to go for disinfection. And the disposal is usually by landfilling. So the treatment can be done on site or in the premises where the waste is generated, or it can be done off site or outside the premises. So depending on the facility available, choice can be made. So on site treatment, first of all, we can do autoclaving. So what is autoclaving?
I'm using steam, high pressure steam. We can like remove the.
Yeah. So basically, it's like having a high pressure and steam. It's basically like a pressure cooker. So this will destroy all the microorganisms. And then microwaving. So microwaving can also be used for heating the waste and killing the bacteria. But if we have 100% dry waste, then it's not suitable. And then hydroclaving. So hydroclaving is an advanced type of autoclaving which uses less energy and water. And here the clean condensate is removed and recycled back to the boiler. So like just like a pressure cooker, here also there will be condensation. So it is recycled back. So there is less water requirement. And then using chemicals. So chemical disinfection is done using chemicals like chlorine, sodium hydroxide, calcium oxide, and so on. Now let's look at some off-site treatment methods. So we've already talked about incineration. That's one of them. And there is land disposal. If the waste is decontaminated, then it can be disposed on land or using landfills.
Pyrolysis.
Sorry.
Pyrolysis.
Pyrolysis, if it can yield energy, then we can go for pyrolysis. If it is containing any plastic which can be converted to fuel, then pyrolysis is possible. And then we can go for deep burial. And what do we do with the shafts? So sharps are devices with sharp points or edges, and
We
they
can sterilize.
sterilize them and then cut or burn them. Even after sterilization, it is highly possible that some residual microbes will be there. So they can be cut or burnt, and they can also be autoclaved and then landfilled. The next category is e-waste or electronic waste. So this is nothing but discarded electrical or electronic equipment. So this can have organics, ceramics, and also some inorganics. This can cause groundwater pollution. And it is used for, I mean, if there are precious metals, then they can be extracted. Um, so it can also contain precious metals, plastics, and glass. So why should we treat e-waste? Because they are known to cause some health impacts. So they can have heavy metals like lead, zinc, nickel, chromium, and so on. So all of these are carcinogens. And there are also some environmental effects. So because of these e-wastes, toxins can be released into the air, water, and soil. So how do we manage e-waste? First procedure is to reduce their
Source reduction.
production. Yeah, source reduction. So we can minimize their production. And also by having proper disposal. So proper disposal is following after doing recycling. So let's see how recycling is done. So for recycling, first we have to collect and transport the waste. And then we have to do shredding and sorting. And then dust extraction. then magnetic and water separation, and waste stream purification, and sale of recycled materials. So these are the steps. First we collect and transport, and then we go for shredding and sorting, and then dust extraction, then magnetic separation. And magnetic separation is using magnets to separate whatever is high in iron. And waste stream, the waste stream is purified, meaning the waste that is coming out of the e-waste, that will be purified separately. And then the sale of recycled materials, whatever is valuable like noble metals and so on, they can be sold. So there are some specific processes which can be used for this. So let's look at those now. The first one is the hydrometallurgical process. Where metals are dissolved into leaching solutions. Second one is pyrometallurgical. So here incineration, smelting, high temperatures, so all this is used. So this is done mainly to recover any precious metals. And then there are biometallurgical processes. So this includes bioleaching, so here metals are digested by microbes. And then they are brought to the solution phase using enzymes. And there is also biosorption, which is absorption using microbes. Okay, so do you have any questions so far?
No, ma'am.
Okay, so
And this precious metals contain like in e-waste.
yeah, there can be gold, platinum, all these metals could be there. So moving on to the questions.
Like you mean gold in an alloy form?
Yeah, not an alloy. Maybe oxides of gold or gold metal as such can be present. Even silver can be present.
Okay.
Okay, so the first question is, what method is used to measure carbon monoxide according to NAAQS? First option is gas chromatography. Second one is non-dispersive infrared. Third one is gravimetric using gravity. Fourth one is using chemiluminescence. So which will be the correct option?
Option B, NDIR.
Yeah. So if the air quality index is 250, then what category will it be? Options are good, very okay. So if AQI is 250, what category will it be? Good, very poor, or satisfactory?
Poor.
Yeah. So good is defined as anything between 0 to 250.
0 to 100.
Oh, 0 to 50.
Yeah, 0 to 50.
Satisfactory is between 51 to 100. Moderate is 101 to 200. Poor is 200, 201 to 300. Very poor is from 301 to 400. And severe is 401 to 500. So generally in India, very rarely we get good or satisfactory. So in most places, it's usually ranging from moderate to poor, especially in the dry season. So the right answer is poor.
Is this range applicable for the whole world or is it for India only?
No, it is specific to India.
Like WHO standards are different, right?
WHO, yeah. See, this is based on national. This is the National Air Quality Index. So this is only applicable for India because I have already told you that this index is formed using concentrations of different pollutants. So the concentration can vary from region to region.
Yes, ma'am.
Yeah. So for a different country, maybe they have a different set of pollutants at different concentrations. So you cannot compare the air quality index.
Is it because of the temperature or weather conditions?
Yeah, of course. We've seen how the temperature and weather influence, right? We've already seen how the uh, environmental lapse rate and adiabatic lapse rate vary, right?
Yes, yes.
So based on that, the pollutant concentration will also vary.
Okay.
Based on the temperature, the wind velocity and direction will change. So all of this will influence the air quality in a particular region. And in some places like Delhi, it's seasonal also.
Yes, yes.
So the next question is, how are waste sharps disposed? So the first option is through incineration and deep burial. Second one is by discharging into drains. Third is by landfilling. Fourth is disinfection and shredding. Okay, so which is the correct option?
Disinfection and shredding.
Okay. So we just saw about this, like cutting and burning is one choice, or we can go for autoclaving and landfilling. So disinfection is usually done by chemical treatment. Or by using autoclave, microwaving. So all these methods are used for disinfection, and then it is followed by shredding. So the question is, which of the following is a source of arsenic? First one, batteries. Second one is semiconductor chips, LEDs, or printer circuit boards.